Okay, we're back. I finished solving. We can go and look at the results here. So if I go to my geometries, plot again. I've given you all different plots here if you wanted to look at different things, but just to keep going with the one we've already created. Let's change this from block group to contour. And by default, it gives you the displacement. So you can see displacements here about 0.15 feet. So whatever that is, a couple of inches. If you want to see the direction of movement, I can add the vectors. So if I go to plus and add vectors, it's showing all of the vectors. So maybe I just want to see the ones on the cutting plane. So again, I can expand this and choose cutting tool. Now I've only got vectors on the cutting plane. And what you can see here is that it's mostly upward motion. So this is really not a very exciting example. We excavate the pit and we get this uplift, but hopefully you get the idea. One trick you can do here with these vectors, often you end up with more vectors than you can see. They're all on top of each other. You can actually choose to skip some of them. So if you look in the attributes here, there's a skip. If I say 10, then it only plots every 10th vector. This gives you sometimes a clearer plot. I can look at the movement on the joint. So I have a plot here called joint. If I just double click on that. Here's the joint. It's already contouring by shear displacement. So I can see the shear displacement on the joint here. Maybe I can plot the geometry on top of this to show where the pit is relative to the joint. So let's do that. Right, so there's the pit and there's the ore body. There's the joint. It's relatively far away from the pit. We're getting shear displacements that are pretty small, probably not significant in this case. Okay, so that's that model. You can, of course, look at histories and other details, but there's one more thing to talk about here, which is painting. So imagine we were doing this model and we had, in this case, we're just modeling the pit excavation itself. It would be relatively easy to model excavating the ore body. But imagine we had a whole bunch of tunnels here representing some sort of infrastructure. You could, in theory, model all of the tunnels as well. This starts to get quite complicated. Certainly in mining, you often have a lot of intersecting tunnels going off in different directions, and trying to model them and excavate them is quite challenging. If we assume that the changes in stress due to the excavation of these tunnels is negligible compared to the change in stress related to the excavation of the pit, we don't necessarily need to actually model the tunnels. We can just import the geometries corresponding to those tunnels and paint information on top of them. So where, which tunnels are seeing high stress changes, which tunnels are potentially seeing high displacements. We're not actually modeling the tunnels, so this displacement is not actually occurring on the tunnels, but it's the displacement that those zones are subjected to because of the excavation of the pit. And this is often very useful. So just to show you how that's done, in this case, I've just made a super simple cylindrical tunnel. In reality, you probably have a whole network of tunnels. So I can import some geometry that represents that tunnel. So let's just run that. We go back to the joint plot. Again, when I import a new geometry, it doesn't necessarily appear by default. So if I go to the model sets, I can add the tunnel. So there it is. So I just made a relatively simple cylindrical tunnel. It's here under the pit. And what I want to do is look at some information about what's happening on this tunnel. Where would I expect high stresses, or where would I expect high displacements? So I can do that by painting information on top of it. So this line here is probably unnecessary, geometry select tunnel, but just to be sure, I want to paint I want to paint information onto that tunnel. I don't want to paint information onto the pit. And so the command looks like this: geometry paint extra block 1. So what this means is that I'm painting information into extra variable number 1. Remember that everything in 3DEC has multiple extra variables up to 128. So in this case, I'm painting information and storing it in extra variable number 1. I could do more than that, and I'll just show that in a minute. But to finish this thought, I'm painting information onto extra variable number 1. The information I'm painting is the displacement, and the component of displacement is magnitude. I could do displacement x or displacement y. In this case, it's just magnitude. So if I run these two lines, go back to my plot, so under the geometry, by default, it's a label, and it's coloring them by set name. So I'm getting different colors for the different sets here. But instead of label, I want to contour, and I want to contour by extra variable number 1. So what you can see here is it's contouring. So the pit and the ore body aren't showing anything. That's all 0. But for the tunnel, because I painted on the magnitude of displacement, I can see down here close to the pit, I'm getting high displacements. And then far away from the pit, I'm getting essentially 0 displacement. And so again, without actually modeling the tunnel, I can paint this information on here and get some indication of what, where there might be some danger areas. And because I'm using extra variables, I could do more than just the displacement. I could, for example, do multiple things at the same time. So I could add another line, paint extra block 2. Let's call it stress. Stress, you don't say component, you say something else. Let's see if I can remember what it is. I hit Control Space there to tell me what I'm doing. So let's see. Paint extra. This is actually a Flat 3D paint extra, but the same thing applies here in 3DEC. Paint extra block for 3DEC. If I say strain, stress, I can just give the components directly, x, x, y, y, z, z, and so on. But often I want to do something like, the maximum compressive or things like that. So stress, it's quantity. Quantity, minimum. Remember, minimum is the maximum compressive stress, because compressive stresses are negative. So what I would do is here say stress, quantity, minimum. Now we'll get the sigma 1 painted on top of that. So now if we go look at the tunnel, the joint plot where I put my tunnel, it's showing the displacements, which was extra variable 1. But if I change this to extra variable 2, it's showing stresses. The contours are wacky because the pit and the geometry have 0. So if I can just hide them, if I go to model sets here and uncheck the ore and the pit, I'm getting a better level of stress here. And it's a little bit weird because, remember, compressive stresses are negative. So I probably want to flip the contours around. So if I go in here to contour and I say reverse, now the red color is the most compressive and the blue color is the least compressive. So again, close to the pit, we're seeing the highest stresses, as you would expect. Okay, that is the end of this tutorial. More to follow soon. Thanks for joining.